Hey, so we're going to go over a little bit of rationalizing denominators. If you had an answer like 1 over the square root of 5, what is that answer with a rationalized denominator? If you said square root of 5 over 5, you're right. If you multiply on top and bottom by radical 5, which we do because that's 1 and it makes the bottom radicand a perfect square, you'll get the answer of radical 5 over 5. How about if we have an answer like 7 over 2 square root 3? How would you write that ratio with a rationalized denominator? If you said 7 square root of 3 over 6, then you're right. Now, do you need to see the work for these? If you do, stay tuned. 1 over the square root of 5. Rationalizing this, I multiply both the numerator and denominator by the square root of 5. 1 times the square root of 5 is square root of 5. Square root of 5 times square root of 5. Sure, that's the square root of 25. Okay, or it's the square root of 5 times itself, so square root of 5 squared, but we don't have all day. You could kind of skip these steps here and just jump right to square root of 5 over 5. Should sort of be common knowledge for you that square root of 5 times square root of 5 is 5. This one works very similarly. If we start with 7 over 2 square root 3, to rationalize that denominator, some people will multiply by 2 square root 3, and there's nothing wrong with that. I'll do it that way first. 2 square root 3 over 2 square root 3. You could multiply a fraction by anything you want as long as it's the same thing on top and bottom because you're really multiplying by 1. Now, 7 times 2 square root 3 is 14 square root 3. 7 and 2 multiply, and the rad 3 just goes along for the ride. Here, 2 times 2 multiply, that's 4. Square root of 3 times square root of 3 multiply, that's 3. Based on the same logic we used right over here. Now, think smarter, not harder. Could you multiply 4 and 3 and take it from there? Sure. Is that also a little silly? Also sure. 2 reasons why I wouldn't. 1, it takes a little bit longer in the long run. And 2, sometimes you guys think 4 times 3 is 7, and that's silly. So what am I going to do to be smarter? Well, let's switch colors. I'm going to reduce 4 and 14. Make things smaller, not bigger. 14 will become 7 when 4 becomes 2. That gives me 7 square root 3 all over 2 times 3, again, not 5, 6. And that's the same answer we had up there. Now, the reason the 2 reduces is because you really could have just reduced it here from the very beginning. So, yeah, that's why if I were doing a question like this one, I would have just started 7 over 2 square root 3, and I would just worry about the square root 3, and take it from there. So 7 square root 3, 2 multiplies by no one, root 3 is 3, and 2 times 3 is 6. A little bit faster. Well, I hope this quick little review helped you,